also known as significant figures. Teachers love them, students hate them.
What is a significant figure?
Significant figures give an idea of the accuracy of a number.
The 4 rules. Rule 1. Non-zero numbers 1 through 9 are always significant.
Rule 2. Zeros located between non-zero numbers are significant.
Rule 3. If there is no decimal point, start from the right. Begin counting when you get to the first non-zero number.
Rule 4. If there is a decimal point, start from the left and begin counting when you get to the first non-zero number.
When you're trying to determine sig figs with numbers that involve zeros, you should think of the buddy system. A zero should not be counted as a sig fig if it does not have 2 buddies. A zero's buddies can be any other non-zero number and or a decimal. A decimal is always counted as one of the zero's buddies, but the 4 previous rules still apply.
109 has 3 sig figs. The 0 has 2 buddies, 1 and 9. 30 only has 1 sig fig because 0 doesn't have 2 buddies.
40 has 2 sig figs because 0's 2 buddies are 4 and the decimal point. 5.0 has 2 sig figs because when there is a decimal point, you look from left to right and begin counting. When you see the first non-zero number, which would be 5, the zero's best friend, the decimal, is there, allowing 0 to count.
0.0280 is an example of rule number 4. This number has 3 sig figs.
1234 has 4 sig figs. This is an example of rule 1.
9180 is an example of rule number 3. There's 3 sig figs.
If there are more than 1 0 in the number and they are sandwiched between 2 non-zero numbers, then both zeros are counted as sig figs. 1001 has 4 sig figs. The 2 zeros are sandwiched between the 2 ones, therefore they count as sig figs.
Why are sig figs useful and important?
Like we said previously, sig figs show the accuracy of a number. Sig figs tell us how to round. They also tell us how to make sure the answer we get from the math problem is not more precise than the numbers that we started with.
Exact versus measured. Exact numbers are infinitely important. Measured numbers are measured with measuring devices, so those numbers have error.
Exact numbers. An exact number is obtained when you count objects or use a defined relationship. Counting objects are always exact. Some examples are 4 pizzas, 2 fish, 3 lamps, and 5 pencils.
Every experimental measurement has a degree of uncertainty. A graduated cylinder has about 17.5 milliliters of water in it. We can easily see that there's at least 17 milliliters of water in it. From there, we have to make a guess for the rest of the measurement. That's where the 0.5 came from. On the ruler, the arrow is located at 2.15 centimeters. The arrow is clearly between 2.10 centimeters and 2.20 centimeters. We have to make an estimated guess. Our guess was 2.15 centimeters.
Percent error is the formula we can apply to determine the accuracy of a measurement. The equation to solve for percent error is the absolute value of the standard value minus the experimental value divided by the standard, then multiplied by 100.
How is precision related?
Greater the number of sig figs, the greater the precision.
Mathematical operation rules. There are specific rules that need to be followed when carrying out mathematical operations and rounding sig figs. Our answer can only be as precise as the least measurement.
Rule 1. Multiplication and division. The answer cannot have more sig figs than either of the original numbers. The number of sig figs in our final answer must be the same as the value with the least sig figs from the calculation. First, determine the number of sig figs your final answer needs to be. Second, do the math. Third, round.
For the equation 347 miles divided by 12.59 gallons, the answer has to have 3 sig figs. Because there can only be 3 sig figs, you have to round your answer. 347 divided by 12.59's solution has more than 3 sig figs. You have to round.
0.7 times 1.5, the answer has to have 2 sig figs. Once again, you have to round your final solution.
Addition and subtraction. The answer cannot have more digits after the decimal point than either of the original numbers. Our final answer must have the same number of decimal places as the value of the least decimal places from the calculation.
00343 has 3 sig figs after the decimal point, and 0.17 has 2 sig figs after the decimal point. So the final answer has to have 2 sig figs after the decimal.
70 has 4 sig figs after the decimal point, and 3.1 has 1 sig fig after the decimal. So the final answer has to have 1 sig fig after the decimal.
Calculations. When calculations involve multiple operations, the normal order of operation applies. Only the final result should be rounded. The result should not be rounded until the end when you have a final solution. The end result should be rounded to the number of significant figures or decimal places of the least precise number of the calculation.
0.83 plus 2.10 times 0.5896. First you multiply 2.10 times 0.5896, which equals 1.23816. Then you add 0.83 to 1.23816, which equals 2.06816. Now you have to round to get the correct number of sig figs after the decimal, so that's why the answer becomes 2.07.
180 is an example of rule number 3. If there, like we said previously, the answer. Every I can't do that. Oh my god, I'm so. Alright, there has about 74. No.
Minus the experimental value. Divide by the standard multiplied by 100.
The greater the number of sig figs, the greater the precision. I couldn't read the last word.
49.7 times 1. This isn't. And you have to round your digits after the decimal point. Either of the original numbers.
Problem. You first multiply. Yeah, that doesn't make sense either. First you multiply. That doesn't sound right. Sorry.